Integration 1, Week 9. So we're starting off looking at primitive functions. So in week 7 and 8 we were looking at derivatives. So here we're going to be looking at the antiderivative or the integral. So we start with our equation, we can differentiate, find our derivative, then from that we can go backwards to our equation here by integrating. We find our antiderivative. So here antiderivative of a function is defined to be the function capital Fx here. So here we use a capital F here such that here capital F dash x f of x here. So sometimes you may know our integral and we want to go back and find our original function f of x. So this is called anti-differentiation and the original function is the primitive function. So looking at indefinite integrals. So here the notation used for finding the general form of the antiderivative, here the indefinite integral, is defined as integral sign, then integrand is equal to our antiderivative plus a constant. We never know what this constant is until we have an application we can apply it to here. So here we use our integral sign. Here our integrand is what we're integrating and our antiderivative is what we end up with plus our constant. So here for our general primitive function here, x to the power of n. So we're saying our change in y dy on dx is x to the power of n. Then here y is equal x to the power of n plus 1 divided by n plus 1 plus c. So if we did it the other way around, if we had y is equal to x to the power of n plus 1 divided by n plus 1 here, plus c, our constant. If we wanted to differentiate that, we would minus 1 from here, and here we would multiply at the front by n plus 1, our original part here. So when we take these into account, we end up with x to the power of n, and these will cancel out, and we end up with our original function here. And we keep our c as our constant. This is our constant of integration. So this is required for each of our indefinite integrals, and one without limits. So here our integral sign here is an infinite sum of infinitesimal summons. So we can keep on going through that later on. Our constant of integration c has to be included. We must remember to put this in when obtaining any indefinite integral. So this is when we're not using any limits. We're not substituting any numbers into our actual integration. When the integrated function is then differentiated, any constant will equal 0. So this will differentiate away to nothing later. However, with indefinite integrals, the constant can greatly influence the integrated function if it increases or decreases y by a number c, sometimes written in lowercase c. So when we're observing a graph of f of x plus c, the effect of c is either to raise or lower our f of x along the y-axis. So if we look at an example from electrical engineering, we've got an alternating current such as a sine wave can be superimposed onto a DC signal. So here we've got y is equal to our sine of x plus c, where sine x is AC and c is the DC. So this is our constant here. So when it's differentiated, our result is cosine of x. And this eliminates the DC component because it's constant. However, when the indefinite integral of cosine of x is obtained, the result is once again sine x plus c. So we'll look at this later on in 9.3 here. So we've got some examples here. For each of the following examples, we want to find our antiderivative here or the primitive function. So we follow our process from before. We said dy on dx is equal to x to the power of n. So y is equal to x to the power of n plus 1 divided by n plus 1 and plus c, our constant. Don't forget our constant. So here we've got our dy on dx is equal to 5 on 2 x to the power of 3 on 2. So we're going to say, well, y is equal to 5 on 2 x, we've got 3 on 2 plus 1. divided by here 3 on 2 plus 1. So here we've got 5 on 2x. Here 3 on 2 plus 1 becomes 5 on 2. And here 3 on 2 plus 1 becomes 5 on 2. So here this is the same. Just get rid of this. So this is the same as having 5x to the 5 on 2 on 2. And here we're dividing by 5 on 2. So we could divide by 5 on 2. Or we can change our sign to times and then we flip our fraction over. So here 5 on 2 becomes 2 on 5. So our 2's will cancel, our 5's will cancel, and we'll have x to the power of 5 on 2 plus c. We should have had our plus c in here all along. Looking at our next equation, we have here dy on dx is equal to 6t cubed plus 2. So we're going to say y is equal to 6t cubed plus 1 divided by 3 plus 1 plus 2, and here we're going to put an x in. So here we can imagine this as x to the power of 0, which is equal to 1. So here this is going to become x to the power of 0 plus 1, or we're adding an x on there, divided by 0 plus 1 here, plus our constant c. So we're going to have 6t to the power of 4 divided by 4 plus 2x be the power of 1, so just that, over 1 plus our constant c. So we can simplify here, becomes 3 and 2. We're going to have 3 on 2 t to the power of 4 plus 2x plus our constant c. Looking at our next example here, we have dy on dx here is equal to 2x squared minus x. So now y will be 2x squared plus 1 over 2 plus 1 here, 3, minus, and now x. So we have here, well, it's x to the power of 1. We're going to add one more here and divide by the same one, 1 plus 1 here, and then put our constant c on the end here. So 2x to the power of 3 divided by 3 minus x squared on 2 plus our constant c. So moving to number 4, we have here dy on dx here is equal to 2 root x plus 3. So we can write this, our first step, we're just going to change this. So we have 2x to the power of a half plus 3, as this is much, much easier for us to work with. So now we're going to have y is equal to 2x to the power of a half plus 1. And here we have a half plus 1 plus 3x plus our constant c. So here we're having 2x to the power of 3 on 2 divided by 3 on 2 plus 3x plus c. So here divided by 3 on 2 is the same as multiplying by 2/3. So here our 3 stays at the bottom and we can just multiply here, the 2 by the 2. So we're going to get 4x to the power of 3 on 2 divided by 3 plus 3x plus our constant c. Okay, if we go to question 5 here. So we have here dy on dx is x squared plus 2 plus x to the power of minus 2. So we treat each of these individually. So y is equal to x squared plus 1 divided by the 2 plus 1 is 3 here, plus 2x, we add our x in, we could divide by 1 but we don't need to, plus x, we've got minus 2 plus 1, and this is going to be divided by minus 2 plus 1 here, plus our constant c. So here we have x cubed on 3 plus 2x, and here we've got x minus 2 plus 1 becomes minus 1. Here, minus 2 plus 1 is minus 1, plus our constant c here. We'll keep it as plus, that is our minus 1 there. Here we've got x cubed on 3 plus 2x minus x to the power of minus 1. So we're going to say 1 on x, or we could leave it as x to the power of minus 1 plus our constant c. So we look now at the statement of the general primitive function. So from the equation of the general primitive function of x to the power of n, we establish here our indefinite integral. We have here our integral x to the power of n dx. We have x to the power of n plus 1 divided by n plus 1 plus our constant c. So this is what we've been using when n is not equal to 1, n is rational. Here we have a special case here. We're integrating dx, here is 1 times dx. So we could write this, we're meaning here 1 by dx here. And we multiply this through is x plus our constant c. And reversing our derivative formula here, when we differentiate x to the power of n plus 1 divided by n plus 1, we get x to the power of n, because we're subtracting 1 and dividing by this n plus 1 here. And here, when we differentiate x, we get 1. So these integrals are referred to as indefinite because x can have any value. So here we can go through a few more examples of finding the indefinite integrals of the following functions here. So here we're going to go through, we'll write this out, we've got 6x to the power of 7 here. So we could write this out, we want to integrate, here's 6 to the x to the power of 7 dx here. So we have 6x, and we're going 7 plus 1. We're dividing by 7 plus 1 plus our constant c. So we have 6 to the power x to the power of 8 divided by 8. We can simplify 3 and 4. We keep our c. Here it's 3x to the power of 8 on 4 plus our constant c. Okay, so if we go to b here, we have 4 here, so 4 divided by x to the power of 4. So we're going to simplify this here, and we're going to change it to 4x to the power of negative 4. So it's the same thing, we're just trying to make it easier to work with. So now we can integrate this. We've got 4x to the power of minus 4 here. So 4x to the power of minus 4 plus 1 divided by our n plus 1 minus 4 plus 1 here, plus our constant c is 4x to the power of minus 3 divided by minus 3. So what we can do, plus our constant c. So we can take our minus out the front. We've got 4 on 3. And our x is to the power of minus 3. So we're going to put our x cubed down the bottom here, plus our constant c. So moving on to c. Here we're going to start by simplifying our actual equation here. So we have 6 root x to the 5. This is the same as 6 x to the power of 5 to the power of a half. So here we have 6x to the power of 5 on 2. So now we want to integrate this. We're going to find, well, y is equal to 6x to the power of 5 on 2 plus 1 plus our constant divided by 5 on 2 plus 1. 6 to the power of x, so this will be 7 on 2 divided by 7 on 2. So we can take our shortcut from before, plus our constant c, so it's going to be 2 times 6 is 12, x to the power of 7 on 2, divided by 7, plus our constant c, and we can simplify this through, so we're going to say 12 root x to the power of 7 on 7 plus our constant c here, or we could leave as before. So now moving on to d. So here we have 1 on root x. So if we've worked out from before, here root x, that's 1 on x to the power of a half. So here we move it up, it's going to be x to the negative a half here. So now when we integrate this, so here we'll end up with y is equal to x to the minus a half plus 1 plus our constant c, divided here by minus a half plus 1. So here minus a half plus 1 is the power of a half. Divided by minus a half plus 1 is a half. So here plus our constant c, it's going to be 2x to the power of a half divided by 1 plus our constant c will be 2 root x plus our constant c. So now if we move on to exercise A, we want to find the indefinite integrals of the following functions here. So ignore those right now, they're on the following pages. So for A, here we want to integrate, here we've got x cubed. So here we're starting off, we've got x to the power of 3 plus 1 divided by this 3 plus 1 plus our constant c is x to the power of 4 on 4 plus the constant c. So for B, we have x to the power of 10. We want to integrate x to the power of 10 here. So we have x to the 10 plus 1 divided by 10 plus 1 plus the constant c is x to the power of 11 divided by 11 plus the constant c. Next we have here, we want to integrate x to the power of 3 on 2 here. So we're having x to the power of 3 on 2 plus 1 divided by 3 on 2 plus 1 plus our constant c. So we have x to the power of 5 on 2 divided by 5 on 2. We multiply here our 2 up, so we're going to have 2x to the power of 5 on 2 on 5 plus our constant c. So looking at D, we just have 6. So remembering from before, when we differentiated 6x, we would end up with 6. So we're doing the same thing here. So here, integrating 6, we're going to have 6x plus our constant c. So now moving on to E. So we have 1 on x to the power of minus 4. Here will be x to the power of negative 4 here. So here we're going to integrate x to the power of negative 4. So we've got x to the minus 4 plus 1 divided by negative 4 plus 1 here plus our constant c. So here x to the power of minus 3 divided by minus 3 plus our constant 3. So now when we look at this, we've got here, we can bring our negative sign out the front. We have here x to the power of minus 3, so we can put 1 on 3x cubed plus our constant c. So looking at F, we just have x here. So we want to integrate x here. So it's going to be x, and here it's the power of 1. We're adding 1 more, divided by the same 1 plus 1 plus our constant c. So it's going to be x squared divided by 2 plus the constant c here. So our next equation, we need to simplify first. So we've got 1 here, we've got root x cubed. So here we're going to say x to the power of 3 divided by 2. We can simplify it further, and it's going to be x to the power of negative 3 on 2. So we want to integrate here minus 3 on 2. We're going to have x to the power of minus 3 on 2 plus 1 divided by minus 3 on 2 plus 1 plus our constant c. So it's going to be x minus 3 on 2 plus 1 gives us minus a half, divided by minus 3 on 2 plus 1 will give us negative a half here plus our constant c. So we can multiply our 2 up, so it's going to be 2x to the power of minus a half divided by minus 1 plus our constant c. So our negative can come out the front, 2 stays up the top, and at the bottom we have root x plus our constant c. Okay, so next, moving on to here, we start by simplifying. So here, x to the power of 5 on 3. So here we differentiate this, x 5 on 3. So we x to the power of 5 on 3 plus 1 divided by 5 on 3 plus 1 plus our constant c. So here 5 on 3 plus 1 more is 3 lots here, so it's going to be 8 on 3 divided by 8 on 3. We multiply out plus our constant c, so it's going to be 3x to the power of 8 on 3 divided by 8 plus our constant c here. So here we can keep our 3 here. It's going to be cube root of x to the power of 8 divided by 8 plus the constant c here. So now we're looking at finding the indefinite integral of a polynomial expression. So here, this is a function that contains several terms, and we work it out using the same rule. We treat each part with our positives and negative signs separately there. So if we would look here, if we wanted to integrate here x to the power of 4, we're going to get x 4 plus 1 divided by 4 plus 1 is 5, so x to the power of 5 on 5. So next here, integrating 3x squared, we have 3x 2 plus 1 divided by that 2 plus 1 here, that will cancel, x to the power of 3. For our next term we have 4x, so here we have 4x, it's power of 1 plus 1 more divided by 2 here, so here 2x squared. And our 7, we integrate the 7, so it's going to be 7x there. And when we put it all together, we put all of it in, so we're saying here we're integrating x to the power of 4 minus 3x squared plus 4x minus 7. We're going to get x to the power of 5 on 5 for our x to the power of 4 minus here x cubed plus here our 4x becomes 2x squared, our 7 becomes minus 7x plus our constant c. So we can do it in one go, just working through each of our terms individually, or we can go through separately. We get the same result there. So looking at exercise B, we want to find the indefinite integrals of the following functions here. So we have here x squared plus 2x plus 5. So our x squared becomes x to the power of 2 plus 1 divided by that 2 plus 1 is 3. Plus 2x, so it's the power of 1 plus 1 more, divided by here our power is 2. Plus 5x here plus our constant c. So we end up with x cubed on 3 plus here x squared, our 2's will cancel, plus 5x plus the constant c. So if we look at B, we're doing the same thing here. We've got 7x cubed minus 3x squared plus 2x minus 24. So we end up with 7x cubed plus 1 here divided by 4 minus 3x power of 2 plus 1 divided by that 3 plus 2x 1 plus 1 more divided by 2 minus 24x plus c. So here we're going to get 7x to the power of 4 on 4. These 3's will cancel, so we're getting minus x to the power of 3. Our 2's will cancel, plus x squared minus 24x plus our constant c.